So here I'm working on a tilting floor application for research. I started with just a basic hinge. This one's a little nicer though. It's got ball bearings in it and it's heavy duty and very smooth actuating. I installed a 5,000 ohm potentiometer into the hinge and basically taken the signal off the center of the rheostat or potentiometer. So basically I get a voltage output that's relative to the position of the hinge. And you can see it's very smooth and predictable. And I'll show you how I got to this point. So the basis of this device here is I started with a hinge. This is a heavy duty hinge. It's got ball bearings in it and very smooth articulating. It's not all rattly and everything. That's what you want to use. I drilled out this end to accept the 1/4 inch shaft of the potentiometer. And I also decided to use these threaded rivet inserts to install threads into the hinge. That just makes it a lot easier when you're assembling it because there's not a lot of room between the plates that you'll see. And this is the tool I use to install the threaded rivet. Basically, this is the rivet. And I put it through the hole that way and had it swell up into this countersunk area of the hinge. Could do it either way. And this is what it looks like when you get done. The rivet's kind of swollen up and gripping onto the material. And that's what it looks like before you start. And again, it's just a rivet that's got a thread insert into it. And basically allows you to put threads into a thin material or material very quickly. And this is one of the tools you can use to do it. It's got you can change the attachment here depending on what size threaded insert you're using. Of course, the shaft here is a 1032 to match the rivet. You can see there's a little serration there that grips onto the rivet. And so what you do is just put it through the hole and hold it and turn here, and it would swell up the rivet. And then you just back this out and remove the rivet. And these are the threaded rivets, and they come in different sizes. And the grips, this tells you, the grip tells you the thickness of the material that you can use this on. And basically this steel here is like 0.135 thick. And then the thread here, that's the screw, 1032, that's what I'm using this time. And they come in all different sizes depending on what you want to use. But anyway, that's the basis for it. Then I just installed this potentiometer and locked it into one side of the hinge and the pin into the other side, so it actuates the potentiometer. So I've got an aluminum plate here that I've drilled and countersunk the holes for the screws here. I want the screws to go in and be flush. Those are for the one side of the hinge. I've got these plastic spacers that I'm going to use. This will hold the hinge up and allow it to have some travel. And so I just install the screws into the threaded rivets. I like to use brass whenever possible. It's a lot easier to cut and work with, and it's also doesn't corrode, and it's strong enough for most things anyway, so it's handy to work with. It's a lot easier than working with stainless steel or hardened steel. And so by changing this length of the spacer, I can vary how much the hinge is, or how much this platform is going to be allowed to move. But for now, this is one with this size here. So we've got the hinge on one side, and now I'm just going to attach the other plate. It's also drilled and countersunk. Actually, I just drilled these plates at the same time and just flipped one of them. I'll put the spacers on there. And then this gets screwed into the other side of the hinge. And this is where, if I didn't have threaded rivets, it would be a little tricky to install this. Not impossible, but this just makes it a little easier. You can kind of just get by with the two hands that you have here. And so what I end up with here is a platform that the behavior system can sit on top of and allow it to pivot. And it's got telemetry signal here that's relative to the angle. And this will be used in research, behavior research. The other thing I need to do is measure this distance and cut a wedge so that it can be locked in the horizontal position. That'll be the next thing I need to do. So I cut a piece of plastic here that I can use to wedge in there and lock the platform, keep it from moving. Works perfectly. I might add a little knob to that. Again, I don't want to spoil them, if you know what I mean.